All right, this is section 9.7, part 1, and we're going to talk about probability. All right, so some key vocabulary that we need to kind of really understand. Okay, so an experiment. An experiment is any happening for which the result is uncertain. So we know what could possibly happen, I just can't predict what will happen. An outcome of an experiment are the possible results. The sample space is a set or a list of all possible outcomes, and an event is any subgroup of that sample space. Okay? So in example 1, we're going to find the sample space for each of the following. So the sample space is just a list of everything that could happen. So if I toss a coin, what could happen? Well, a head could appear, or a tail could appear. So we write the sample space like this. Sometimes we call it S, and we define it as, and we put curly braces, an H or a tail. And then we end the curly brace. Now, what happens when we toss 2 coins? Okay, so we're going to start it off. Well, what could happen is we could get a head and a head, or we could get a head followed by a tail, or we could have got a tail followed by a head, or we could have got a tail followed by a tail. Now, what happens when we do 3 coins? Well, there's going to be many more possibilities. All right, so we could get all 3 heads, or we could get 2 heads followed by a tail, or we could get a head, a tail, and then a head, or a head followed by 2 tails, or all 3 tails, or a tail, a head, and a tail, or a tail, a head, or a tail, and a head. Okay? So on Edpuzzle, why don't you write the sample space when you toss 1 coin and roll a die? All right, let's check our answer. So you should get the following. You could get a head followed by a 1, a head followed by a 2, a head followed by a 3, a head followed by a 4, a head followed by a 5, a head followed by a 6, a tail followed by a 1, a tail followed by a 2, a tail followed by a 3, a tail followed by a 4, tail followed by a 5, and a tail followed by a 6. And that's going to be all the possibilities. So if you notice, there are going to be 12 outcomes in this sample space. Now, just to tie this in, you could have done this with the fundamental counting principle. So if we look at the coins, there are 2 coins, heads or tail possibilities, and there are, for the die, 6 possible faces. When you multiply those together, you get 12. And that's another way to verify that you have listed all the possible outcomes of your sample space. All right, so what is theoretical probability? Okay, when all outcomes are equally likely, the theoretical probability that an event A will occur is defined as, we call this the probability of A, okay, of event A, is equal to the number of outcomes in that event over the total number of possible outcomes. So here's a way to picture it. So if I'm only concerned with the probability of event A, I count how many events, things that happen in A, divided by the total number of outcomes, and that's how I get a probability. Some key ideas. Okay, key idea number 1, all probabilities have to be a number between 0 and 1. It could be a percentage also, okay, but you can't have any negative probabilities, and you can't have any probabilities above 1. If a probability equals 1, then that event can never ever happen. It's also called an impossible event. If an event, a probability of an event equals 1, then it always has to happen, and it's also called a certain event. So the closer to 1, the more likely the event is to occur. The closer to 0, the less likely it is to occur. All right, let's try example 2. So you draw 1 card at random from a standard deck of cards. Let's find the probability that the card is a diamond. So the probability that we have a diamond is equal to, so there are 13 diamonds out of 52 cards. When you simplify that, you get 1/4. All right, what about the ace? So the probability that our card is an ace is going to equal Aces, right here. 1, 2, 3, 4 aces out of a total of 52. And that's going to simplify to 1 over 13. All right, now in Edpuzzle, put your answers for practice 2A and B. All right, so the card is a face card. So the probability we have a face card. All right, so that's going to equal king, queen, jack, and you have 4 suits. So there are 12 out of 52, which simplifies to 3 out of 13. All right, probability we have a red card. Well, there are 26 out of 52 cards, which equals 1/2. All right, let's try example 3. All right, what if I roll 2 6-sided dice? Find the probability that the sum is 4. So the probability that the sum equals 4 is going to equal. So I look at all the possibilities. 1 and 3, that equals 4, doesn't it? 2 and 2 is 4, and this is 4. So it looks like there are 3 possibilities out of a total of 36 possibilities. And that gives me 1/12. All right, probability that the sum is at least 10. Well, that means it could be 10, or the sum could be 11, or the sum could be 12. All right, so looking, 10s. It's looking like my 10s, and I'll use this color for 10, are going to be right here. This one's a 10, this one's a 10, and this one's a 10. All right, so that's going to give me 3 out of 36. 11s, all right, those are those 2. So that's going to give me 2 out of 36, plus my 12, which is this case, and that's going to give me 1 out of 36. So that gives me a total of 6 out of 36. And that simplifies to 1/6. All right, and then C, the sum is less than 3. Well, there's only one way to have a sum less than 3, and that's going to be 2. And there's only one 2, so that's 1 out of 36. All right, let's try practice 3. So why don't you answer A and B on Edpuzzle. All right, so we want the probability of getting a 4 plus the probability of getting a 5 plus the probability of getting a 6. Okay, so it looks like there's going to be 1, 2, 3 ways to get a 4. There's going to be 1, 2, 3, 4 ways to get a 5. And there's going to be 1, 2, 3, 4, 5 ways to get a 6. When you add those, you get 12 out of 36, which equals 1/3. All right, a sum of 8, probability of an 8. So that it's going to be 1, 2, 3, 4. There are 5 different ways to do that. All right. Next idea in probability is compound events. So if event A and B are, if A and B are events in the same sample space, then the probability of A or B occurring is given by the following probabilities. Okay. So we have a couple cases. Events A and B can overlap. If they have an overlap, that overlap is called the intersection, okay? And it's sometimes abbreviated with this upside down U, okay? When I'm finding the total of both of them, including that intersection, that's called the union, and that looks like a U. If there's no overlap, these are called mutually exclusive events. Okay, or sometimes known as disjoint events. Okay, so some examples, things that overlap or happen at the same time. A heart or a jack. Well, you can have a jack of hearts. You can have these at the same exact time, so that's why these overlap. Things that don't overlap, a heart or a diamond. Well, a heart can't be a diamond. There's no way these two things can be the same, so there is no overlap. So we have a probability. If things overlap, the probability of A or B occurring is equal to the sum of the two probabilities minus the intersection. And the reason you do that is because when you have an overlap and you start adding, so here's event A, and you start adding event A, and then we go to event B, and you start adding event B. Did you see what I just did there? I double counted that intersection. So to fix this, I subtract one of those intersections. Now, if there's no overlap, you don't have to worry about an intersection because you just add these both together and that is your union. All right, let's try example 4. So a card is drawn from a standard deck of playing cards. What is the probability that the card is a club or a face card? So probability that the club or face. Well, that's going to equal the probability that you have a club plus the probability that you have a face. And then we have to think to ourselves, can you have both? Yeah. So then you subtract the intersection, club and face. All right, so there are 13 clubs. There are 12 face cards. And there are 3 clubs that are also face cards. And then when you do that, you get 13 out of 36. All right, B, what is the probability that a card is a 10? So the probability you have a 10 or less than 4. Well, can a card be both 10 and less than 4 at the same time? No. So how many are are 10? There are 4 10s in a deck of cards. And then there are 8 cards that are less than 4, strictly less than 4. When you add those, you get 12 out of 52, and you get 3 out of 13 as your answer. All right, again, let's try practice number 4, and let's see what you get. All right, so probability that we have a card that is red or a 2. All right, red card. So there are 26 out of 52 red cards. There are 4 2s, but there are 2 red 2s that I double counted. So I fix that, and I end up getting 28 out of 52, which equals 7 out of 13. All right, what is the probability the card is a face card or a 5? So there are 12 out of 52 face cards plus 4 out of 52 5s, and there are no face cards that are also 5s, so we end up getting 16 out of 52, which equals 4 out of 13. All right, now next concept, independent events. 2 events are independent if the probability of A and B occurring is equal to the product of the 2, okay? And also that the probability of one happening has no effect on the other happening. So example 5. A 20-sided dice is tossed and a card is drawn from a deck of cards. Now, when I toss a die and draw a card, does one have anything to do with the other? No. Okay. So for an unfair coin, probability of heads is 0.7 and tails is 0.3. What's the probability of getting an 11 on the die, okay, and drawing a face card from a deck of cards with rolling tails and unfair coins? Okay. So first step, we have a 20-sided die. Okay. The probability of getting 11 on a die, there's 1 11 out of 20 times face card. There are 12 out of 52 times unfair coin. Okay, and we want a tail, so 3 out of 10. When I multiply those together, I get 9 out of 2,600, and there is my probability. All right, why don't you guys try practice 5, A and B. All right, so for part A, a fair coin is tossed 3 times. So here is toss 1, here is toss 2, here is toss 3. When I multiply those together, you get 1/8. That is the probability. All right, B, you have a bag of marbles that contain 5 red, 6 black. You have a jar that contains 3 red and 7 blue marbles. You reach into the bag and take 1 marble and 1 from the jar. What is the probability that both are red? Okay, so this is going to be the bag, and this is going to be the jar. Okay, we want red. So in the bag, we have 5 out of 11 red. In the jar, we have 3 out of 10. When I multiply those together, you get 15 over 110, which simplifies to 3 over 22. All right, Now, the complement of event is exactly the opposite. So if you're looking at a Venn diagram of this situation, okay, if this is event A, then out here is the complement of event A. So this is exactly the opposite. The total box has to equal 1. All right, so here's some probabilities, and let's find the following. So what is the probability of the complement of event E? All right, so that's going to equal 1 minus the probability of E. So that's going to equal 1 minus 0.57, which equals 0.43. All right, probability of F, which is going to equal 1 minus the probability of the complement of F. So that's going to equal 1 minus 3/7, which is going to equal 4/7. All right, Y, probability of Y is 1 minus the complement of Y, which is going to equal 1 minus 0.16, which is going to equal 0.84. And then probability of the complement of A is going to equal 1 minus the probability of event A, which is equal to 1 minus 2/3, which equals 1/3. All right, how about example 7? So 2 fair-sided dice are rolled. What is the probability of getting a total that is less than or equal to 10? Now, that is a 2, a 4, a 5, a 3, all these different possibilities. Sometimes it's easier to do the exact opposite. So the probability of getting less than or equal to 10 is going to equal 1 minus the probability of getting greater than 10, which is also known as 1 minus the probability of getting greater than or equal to 11, which is 1 minus the probability of 11 plus the probability of a 12. So that's going to be equal to 1 minus the probability of an 11. There are 2 ways to do that out of 36. And a 12, there's 1 out of 36. So when you find that, you end up getting 33 out of 36, which is 11 out of 12. So the complement can save time sometimes with problems. All right, why don't you try practice 7, both A and B. All right, for practice 7, I would do 1 minus the probability of getting all heads, which is going to equal 1 minus 1/8, which is going to equal 7/8. All right, for PB, the first thing you find is the probability of getting a queen, which is 4 out of 52. So the probability of getting a not queen is going to be 1 minus 4 out of 52, which equals 48 out of 52, which equals 12 out of 13. All right, example 8, practice 8. The following figures show the number of colleges and universities in various regions of the United States. So we have a whole bunch of data. The first thing I'm going to do is find the total by adding up all of these. So we have 604, we have 311, we have 471, we have 682, we have 266, 667, I believe, 797, 294, and we have 438. When I add all those numbers together, you get 4,490. That is my total. So in part A, what is the probability an institution selected at random is one of the central regions? So the probability of having a central is equal to. All right, so I'm looking for anything that says central. Okay, adding those up, you get 471 plus 682 plus 438 plus 254 divided by my total, 4490. That's going to equal 1885 divided by 4490, which equals 377 divided by 898. All right, part B. What's the probability we have Southern? So the probability of Southern is going to equal any part that says Southern in the name. So we have 797 plus 294 plus 438, all divided by 4490. And that's going to equal 152, I think, let me see, 8, 6, 11, 9, over 4490. And then last but not least, C, what is the probability the institution is either Southern or Atlantic? All right, so probability that we want Southern or Atlantic is going to equal the probability of Southern plus the probability of Atlantic, but there are some states that are both Southern and Atlantic. All right, so Southern states. If I added up all the Southerns, you get 1529 divided by 4490. My Atlantic states are going to be 1424 divided by 4490. And then the Southern Atlantic states are 797 divided by 4490. You end up getting 2156 divided by 4490, which simplifies to 178 divided by 2245. All right, and then our last example. So the Human Resources Department of a company has compiled data showing the number of years of service for each employee. So here's my data. All right, so step one, if it's not already given to you, is to find a total. Add up all those numbers and you get 529. A, what is the probability chosen random has 4 or fewer years? So the probability of 4 or fewer is equal to 4 or fewer, 157, out of the total, 529. Done. Okay, part B, what is the probability that we have 9 or fewer? All right, so 9 or fewer is going to be 157 plus 89 divided by 529, which is going to give us 246 divided by 529. And then last but not least, C, what is the probability that an employee chosen at random has 10 or more? So the probability of 10 or more is actually going to be easier to find the complement. 1 minus the probability of 9 or fewer. Why? Because I just found that in the previous problem. So 1 minus 246 over 529 equals 283 over 529. All right, now you can do your homework.